Hello everyone, and welcome to this training session on Linux file permissions. Today, we'll be diving into the core concepts of how Linux manages access to files and directories. This presentation will provide you with a solid understanding of file types, permissions, and how to effectively manage them. In this session, we'll explore the fundamentals of file permissions in Linux. We'll cover the different file types you'll encounter, the various levels of access that can be granted, and how ownership plays a crucial role in security. By the end, you'll be able to confidently navigate and manage file permissions in a Linux environment. We're starting with the basics. This section will lay the groundwork for understanding the more complex aspects of file permissions. We'll define key terms and concepts that are essential for grasping the overall system. In Linux, everything is treated as a file, but not all files are created equal. We'll explore the different categories, including regular files, directories, and symbolic links. Understanding these distinctions is crucial for managing permissions effectively. Regular files contain data, programs, or text. Directories, on the other hand, act as containers for other files and directories. Symbolic links are pointers to other files, offering a shortcut. Next, we'll discuss the three permission types: read, write, and execute. Read allows viewing file content or listing directory contents. Write permits modifying files or creating/deleting files within a directory. Execute allows running a file as a program or entering a directory. These permissions can be granted to three user classes: owner, group, and others. Understanding these classes is key to controlling access. The owner is the user who created the file. The group is a collection of users with shared access needs. Others refers to all users who are neither the owner nor members of the group. Now, let's delve into how these permissions are represented. We'll examine both symbolic and numerical notations. This will enable you to interpret and modify permissions using different methods. Symbolic notation uses letters like R, W, and X to represent read, write, and execute. Numerical notation uses octal numbers to represent the same permissions. We'll see how these translate. Symbolic versus numerical. For example, RWX translates to the number 7. This is because read is 4, write is 2, and execute is 1. 4 plus 2 plus 1 equals 7. We'll practice converting between these notations. Now, let's explore the chmod command, which is used to change file permissions. We'll cover how to use it with both symbolic and numerical notations. This is a fundamental tool for managing access. The chmod command allows you to modify permissions for the owner, group, and others. You can add, remove, or set specific permissions using symbolic or numerical modes. We'll look at examples. The chmod command. For instance, chmod u plus x file.txt adds execute permission to the owner. Conversely, chmod gw file.txt removes write permission from the group. Practice is key to mastering chmod. Next, we'll discuss the chown command, used to change file ownership. This is important when transferring files or managing user access. Understanding chown is crucial for system administration. The chown command allows you to change both the owner and the group associated with a file. Proper use of chown ensures that the correct users have the necessary privileges. We'll explore its